I'm going to introduce you to scientific notation. Numbers like 45 or 112 are easy to write and use just as they are. But what about really big numbers like 435 million? A number that big is too clunky to write out. Also, what about really small numbers like 0.00000023? I'm going to run out of space pretty quickly if I use these numbers as is. The study of chemistry can involve a lot of these really big and really small numbers. Scientific notation is what's going to help us deal with this kind of number, and it does this using powers of 10. Let's take that really big number I showed you and write it using scientific notation. To express this number in scientific notation, I'm going to take 4.35 and multiply it by 10 raised to some power. I can figure out what exponent to use by counting how many spaces I have to move to the right to get from the decimal I have written here to the end of the original number. 1, 2, 3, 4, 5, 6, 7, 8. So in scientific notation, I have 4.35 times 10 to the 8th power. That is a little more compact and convenient than the way I had it before. How about really small numbers, like the one I showed you earlier? I can use powers of 10 to express this number in a more convenient way. But here, the exponent that I put on 10 will be negative. So I'll take 2.3 and multiply it by 10 raised to some power, which will be negative. I can figure out what that power is by counting how many spaces I have to move to get from this decimal to where the decimal was in the original number. 1, 2, 3, 4, 5, 6. So in scientific notation, my number is 2.3 times 10 to the negative 6th power. These are some of the basic processes you can use to express really big and really small numbers in scientific notation.